Today we're going to do Test 2 Electric Boogaloo for my Intro Statistics class. So if you want to see more videos like this, subscribe, smash the like button, and join me in the simultaneous sip. All right, let's get started. Question 1. A psychologist wants to know if the difficulty of a task influences our estimate of how long we spend working at it. She designs 2 sets of mazes that subjects can work through on a computer. One set has easy mazes and the other has hard mazes. Subjects work until told to stop. They are then asked to estimate how long they worked. The psychologist has 30 students available to serve as subjects. A. Explain why this is an experiment rather than an observation. B. The experiment is described as randomized, controlled, and double-blind. Explain what each of these words means in the context of the experiment. And C. Use Table B to assign 3 of the subjects into the hard maze group. Tell me which row you started on. So for part A, we want to explain why this is an experiment. And it's an experiment because she is not just observing the subjects. Right? If she just observed them, then it would be an observational study. But what she's doing is she's comparing a control group and the treatment group. So she's comparing results from a control group, which would be the easy maze, and the treatment group, which would be the hard maze, and seeing how these results differ. For part B, we need to describe what each of these words means. What does randomized, what does controlled, and what does double-blind mean in the context of our experiment? So randomized. So what does randomized mean? It means that subjects are placed into their group. So into the easy maze group or the hard maze group randomly. We had a random digit generator, or a table B would do it randomly for us. Controlled, well, what does it mean that the study is controlled? It means the effects of the hard maze, okay, so that's going to be our treatment, are compared to the effects of the easy maze, which would be our control group. So there's a control group where they just do an easy maze. Of course, the subjects, it's best if the subjects don't know which maze they got. So that's where double blind comes in. So double blind means the subjects, well, that's single blind, and the people handing out the mazes. So both the subject and the person handing out the mazes has no clue if the easy maze or the hard maze was just handed out. For part C, we need to use Table B, and I'll just use this first row. We're looking for numbers between 1 and 30. So 19, 22, 39 is too big, so let's just throw it out. 50 is too big, 34, too big, but 5 is in the right range. And we would go on until we get everybody. Question 2. As you know, Dr. Weselcouch, that's me, is a YouTube star. He has so many great videos, it's hard to keep track of his many accomplishments. Late one night, he thinks about some of his future accomplishments. Let A, B, and C be the events that Dr. Weselcouch accomplishes. A, 10,000 subscribers by 2021. B, stats video goes viral. Or C, channel gets shut down by the copyright police. Dr. Weselcouch writes down his personal probabilities for accomplishing these events. P of A is 0.6, P of B is 0.5, P of C is 0.1, P of A and B is 0.15, P of A and C is 0.05, and P of A and B and C is 0.05. And last, the conditional probability of B given C is 1. Part A, make a Venn diagram of the events A, B, and C. Mark the probabilities of every intersection involving these events. B, what is the probability that Dr. Weselcouch accomplishes none of these events? C, what is the probability that Dr. Weselcouch accomplishes both having a stats video go viral and get shut down by the copyright police, but does not reach 10,000 subscribers by 2021? D, if Dr. Weselcouch's channel gets shut down by the copyright police, what is the conditional probability that he reaches 10,000 subscribers by 2021? And E, if Dr. Weselcouch's channel reaches 10,000 subscribers by 2021, what is the conditional probability that he has a stats video go viral? So we'll let A be the circle on the left, B be the circle on the right, and C be the circle below. Well, we're given all these probabilities except for probability of B and C. And we know probability of B and C is equal to P of C times P of B given C. And looking above, we see that the probability of C is 0.1 and the probability of B given C is 1. So the probability of B and C is 0.1. Now what we want to do is start from the inside and work our way out. So we'll start with all three of the events happening. That's 0.05. Next, let's do B and C. So the whole oval will equal 0.1. So that section must be 0.05. Right? Because 0.05 plus 0.05 gives us 0.1. P of A and C adds up to 0.05. So that this section must be 0 because we needed to add up to 0.05. P of A and B adds up to 0.15, so that's going to be 0.1 there. The whole C circle should add up to 0.1, and it already does, so we have a 0 for this bottom section. The whole B circle should add up to 0.5, so there's 0.3 remaining. And the whole A circle should add up to 0.6, so that section is going to be 0.45. So next, for part B, what is the probability that Dr. Weselcouch accomplishes none of these events? Well, that's 1 minus the probability that any of the events occur. So probability of A or B or C. So that's 1 minus, well, the quantity 0.45 plus 0.1 plus 0.3 plus 0. I'm just reading off all the entries from the Venn diagram. Plus 0.05 plus 0.05 plus 0, which is equal to 1 minus 0.95, which is equal to 0.05. So there is a 0.05 probability that none of the events happen. For part C, we want the probability of B and C, not A. So that's just really asking us to look at our Venn diagram. So I'll highlight the section. It's this section here. Basically wants us to write down what is the number in that section. And it's 0.05. Right? You can see that section is the one that satisfies B and C, but not A. Next, we want P of A given C, which we know is P of A and C over P of C. And we're given all of those values, so we just plug them in. So that's 0.05 over 0.1, which is 0.5. For E, we want to find the probability of B given A, which is the probability of A and B, over the probability of A. And again, we were given these, so we just plug them in. P of A and B is 0.15, P of A is 0.6, This division is 0.25. Question 3. The average test score on a statistics final is 80 points with a standard deviation of 10 points. A. If I randomly select 30 students, what is the probability that their average test score is greater than 90? And B. Find the sample size such that 95% of samples of this size have an average test score within 1 point of the mean. So to solve this problem, we're going to use the central limit theorem, which says the distribution of the average, so the distribution of x bar, is approximately normal, and that normal distribution has a mean of mu and a standard deviation of sigma over root n. And in this case, we know mu is equal to 80, that was given to us, and sigma is equal to 10. So let's look at A. So if I randomly select 30 students, that means n equals 30. Well, we want to find the probability that our average is greater than 90. With our distribution, which is normal, with a mean of 80 and a standard deviation of 10 over root 30. So let's clean up that standard deviation, and we have our normal distribution with a mean of 80 and a standard deviation of 1.8257. Okay, so let's head over to Minitab, and we're going to use Minitab to find the probability that x bar is greater than 90. So let's type in our mean, type in the standard deviation. We have a specific x value, which is 90, and we want the right tail, greater than 90. And when we run this, we get a probability that is so small the computer rounds it to 0. So it is very unlikely that if you randomly select 30 students, the probability, it's very unlikely their average will be 90 or greater. So this probability is approximately 0. For part B, we're going to use the 68, 95, 99.7 rule, which says that 95% of the observations, or about 95% of the observations, lie within 2 standard deviations of the mean. So we want 2 times the standard deviation to equal 1. Okay, and what is the standard deviation of our distribution? It's 10, which was sigma, over root n, and we're going to try to solve for n. So let's multiply both sides by root n. We get 20 equals root n. Square both sides, and we get n equals 400. Question 4. An underground casino opened in the basement of one of the dorms on campus. They play a made-up game called Maroons. To play Maroons, you roll 2 6-sided dice. One of them is maroon colored, hence the name. You win if the maroon die is 1 or 4, or the sum of the dice is 7 or 10. Otherwise, you lose. A. What is the probability you win the game? B. Suppose you play the game 100 times. Approximately, what is the probability that you win 50 or more times? And C. Suppose you play the game 8 times. What is the probability that you win exactly 4 of those games? So I listed out the sample space for when you roll 2 dice. And here I'm highlighting when the first die is a 4 or a 5. And now I'm going to highlight when the sum of the dice is equal to 7 or 10. And what we'll do is we'll just count every roll that's highlighted. And if it's highlighted twice, well, we'll only count it once. So when we count all of these, we see that P is equal to, well, we count them and we get 17 out of a total of 36. So the probability is 1736, which we could round to 0.4722. Okay, part B. Suppose we play 100 times, what's the probability we win 50 or more? So here we have n is equal to 100, and this is a binomial distribution. So the distribution is approximately normal. With mean, n times p, and standard deviation, the square root of n times p times 1 minus p. So when we plug all of this into a calculator, right, we already know n and p, we get a mean of 47.22 and a standard deviation of 4.9923. And we want the probability that x is greater than or equal to 50. So let's use Minitab for this again. So we go to probability, and we'll type in our mean, and we'll type in our standard deviation. Again, right tail with a specific x value of 50. We run, and you can see that's the probability, or that's approximately the probability. This is just an approximation. So the probability of x being greater than or equal to 50 is about 0.288812. What is the probability that x is exactly equal to 4 when n is equal to 8? Well, that's 8 choose 4 times 0.4722 raised to the 4th power times 1 minus 0.4722, so 0.5278 raised to the 8 minus 4, which is the 4th power. Plug this into a calculator, and we get 0.2701. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.